Hey, we are going to evaluate a couple of limits today, and this is the first one that we're going to do. The limit as x approaches pi over 2 from the left of ln of cosine of x. Okay, sometimes when you're looking at a function, you have to pay attention to not so much how it behaves like algebraically, but like especially when it's trig function, you want to look at how it behaves in a geometric sense. So as x approaches pi over 2 from the left-hand side, let's look at what happens to cosine of x. To do this, we're going to need a unit circle. And of course, I'm very good at drawing circles. Pay no attention to the lumpiness. As x approaches pi over 2 from the left. Now, from the left means that it is increasing up to pi over 2. So that means whoop, we are coming at the pi over 2 position, which is right there. We're coming at it from below. Now, from below in the unit circle means that you do increase towards it, which is why I've drawn the arrow going in that direction. So what I want is to say what happens to cosine of x as x approaches pi over 2 from the left. Along this path, cosine of x approaches, now think about it, cosine is the x coordinate, so it's going to approach 0, and it's going to approach it from, it approaches 0, but does it approach it traversing through positive numbers or through negative numbers? Well, in the first quadrant, cosine is positive. So cosine of x will approach 0. We can say from above, or what that means is through positive numbers. This is to distinguish between what would happen if we were coming at it from this direction, in which case it would be going to 0, sure, but it would be doing that, tracing through all the negative numbers on the way there. But we don't want that. We want to come at it from the positive numbers, because that's what this implies. So now we want to take the ln of these numbers that are going to 0. Think of what happens to ln. Here is its graph. And what's happening is we're taking the inputs for ln to be approaching 0 from the right now. Now, I know I'm using right, left, positive, negative, above, and below. I'm using these terms interchangeably. You should be comfortable with that, because as cosine of x approaches 0, going through positive numbers, what that means is that ln is going to be evaluating numbers that are going to 0 from this direction. But as you can see, based on where those green arrows are going, these inputs for ln are approaching 0. Well, guess what that means? That means that this limit is going to be going towards negative infinity. So this limit is equal to negative infinity. There's no real way to get this algebraically, at least at this step in what you know about math. Maybe later when you know a whole hell of a lot of calculus, you'll be able to do that. But it's possible to work this out just based on geometry and based on the behavior of ln. If you want to get rigorous about it, you can say as x approaches pi over 2 from the right, cosine of x approaches 0. Oh, wait, I should have said as x approaches pi over 2 from the left. Then cosine of x approaches 0, and it approaches it from the right. Okay, so the limit as x approaches pi over 2 from the left of ln cosine x is going to be the same as the limit as x approaches, as x approaches 0 from the right of ln x. And from the graph of ln x, or from the definition of logarithms, we can see that that has to be negative infinity. Okay, let's go to the next problem. That's going to be this limit. Oops, let me get the blinking cursor off there. Okay. What you do not want to do, is say that this is going to be equal to the limit as x goes to 1 of 1 over x minus 1 plus, by which I mean that, plus the limit as x goes to 1 of 1 over x squared minus 3x plus 2. This is no, no, no. In most cases, the limit that we have typed at the top of this page will be equal to what I've just written. However, in some cases, the limits individually right there will fail to exist, and then you can't separate them out. Like this limit right here, guess what? As x approaches 1, that limit doesn't exist. And it's not even one of those fail to exist where it's like equal to infinity. It literally fails to exist because at 1, this is going to be positive on the right and negative on the left. So this limit doesn't exist even in the equals infinity or equals negative infinity sense. It's actually nothing. So when you package them together, when you take the limit of both of them considered together, then you can combine them algebraically, and sometimes some nice stuff happens and you end up with a finite limit, even though each one of the individual limits would have been infinite. So we're going to keep them together. We're not going to separate them out. But they do need common denominators in order to combine them. So we do get to do some interesting algebraic stuff with them. So 1 over x minus 1 plus, and the big ticket with common denominators in algebra is factor. So factor, the second one, this will be, that looks like minus 2 minus 1. X minus 2, x minus 1. And it's a good thing we factored because they share that factor. And so I'll be multiplying this one by x minus 2 on the top and bottom, meaning that this whole thing is going to be x minus 2 plus 1. And this plus 1, I mean to line up with that, because now they will just have a single denominator over x minus 2 times x minus 1. Okay, well, x minus 2 plus 1, that's obviously equal to x minus 1 over x minus 2 times x minus 1. And looky, looky. The difficult thing about this limit was that x was approaching 1, which made it impossible to plug in. So usually what you hope for is that after you do some algebra, that you get a cancellation. And then it does become possible to just put the number in as is. That's exactly what happens here. Because look, beep, beep, x minus 1 is gone. Vamoose. We're never going to say its name again. So this is equal to 1 over x minus 2. Okay, so because all we did was do algebra to the inside of the limit of the original will be equal to the limit of this thing. So this is equal to the limit as x approaches 1 of 1 over x minus 2. Now that the 1 is like no longer a problem, it's been removed as a factor from the bottom, we can just plug it in straight. So this will be 1 over 1 minus 2. That's 1 over negative 1, or simply negative 1. If we had separated these two limits into the limit of this one plus the limit of this one, we would have gotten into some real hot water because those limits individually don't exist. And then we would have ended up saying, oh, well, this must not exist. But when you combine them and then take the limit of the combination, you can actually show that that does exist. Cool, huh?